Hello, I'm Rohan. Can you hear me back?
Yes, sir.
Okay, cool. I'm Rohan. So I'll be demonstrating some of the routing functionality in the VeloCloud SD-WAN, what simplicity VeloCloud SD-WAN has brought in for the SD-WAN product. This is just a typical enterprise topology. You can see there are multiple branches, different type of branches. One of the branch with connections only to internet. There are branches where there are connections to MPLS and internet, different type of branches. I have just shown 4 different branches. You have a data center, a legacy site, you can see, which is just have connection to the MPLS. So if I have to reach that legacy site, and if the branch is with 2 internet links, then I'll have to use data center as a next hop to reach that legacy site. Now, all of this routing, if you see, if I just add 100 more sites here, sorry, I didn't have the space, but if I had 100 more sites for a network admin to do routing configurations or route preferences or any route changes, it will be complex. They will have to touch multiple elements of a site. They have to go downstream routers, layer 3 switches. They'll have to do the configuration route changes depending on the branch site. But with VeloCloud SD-WAN, we bring in the simplicity. And that's where that simplicity comes to play, where we define a global unified routing table for the enterprise. And what we call it as a OFC, Overlay Flow Control Table. So that's a single view you get. And let me actually directly go into that routing table and quickly show you the OFC table, which will give you a unified view for the enterprise. So you can see here on the top, we have preferred VPN exits. That's where if you have to reach a specific subnet, it will show you that these are the possible 4 ways you can reach that end subnet. Edges, partner gateway, routers, hub. At the bottom, you can see the subnet and how we are learning those subnets, either through OSPF, BGP, directly connected, static routes. It shows up here. It also shows up the preferred VPN exit points. Maybe I'm learning a specific subnet through multiple sites, through hub site, to a branch site, or through underlay. So I can change the preference here with a single click. That's where the simplicity comes to play.
So the analogy here is, instead of going to see the show IP route command on the Cisco boxes, you have to go edge by edge by edge and see show IP route, and then see the same destination on each of the routers and try to debug your network. What we are saying is, what is important is, how do I reach a certain destination? That is more critical. And then how do I get through there? What are the possible options is what we are demonstrating. And then for those options, whether you use dynamic branch to branch or exactly what VPN topology you enable, is driven through the profile. But it really simplifies, because now I have all the destinations in my network listed there.
So another quick analogy that I want to make is, like, you can sort of like treat TSD1 domain as one ginormous router. And each of the branches now become a port on that router. And we're looking at the routing table of that router, basically. So you get a global overview of all of the routers.
So I don't have to go to each individual site and do the configuration. From OFC table, I push my preferences that data center site is going to be the preferred exit point for a particular destination. And these are the 2 use cases I quickly wanted to talk about. So there is one site where I've zoomed in, and this site, I don't want to be a transit site if it has to reach a legacy site. That's the first use case I wanted to demonstrate. The second one is where we are running OSPF, we are running BGP on the MPLS side, and we'll see how we can influence a local site just with a single policy push from the OFC. Depending on the site, what kind of a local preference is set, we can change our overlay routing costs so that we prefer always the MPLS. A typical use case would be a customer or an enterprise wants their critical traffic to always go on MPLS site. Or maybe because of the compliance reason, they want their traffic to go on the MPLS site. So we can influence with a single policy push. I don't have to create multiple templates for each site, because each site is different. I might be having a SFO site running OSPF with OE1, or a different site, a second branch site with OE2. So with a single policy push, we'll make sure that if it has to go underlay, then the underlay routes are always preferred. And the overlay routes which we are receiving, the cost which we are receiving from the OFC table, our overlay flow control table, those keeps changing dynamically, depending on the metrics which is set on the downstream routers.
Is there any...
Sorry, go ahead.
All right, I don't mind. Is there any compelling... Could you put the diagram back up?
Oh, yeah, sure.
So is there any compelling reason to have the situation on the right other than during a migration where... Right.
Yeah, like a lot of...
You would want to run tunnels even over MPLS
exactly.
as well, right?
Yeah,
so overlay.
Exactly. So the underlay is more of a migration, or it is more of a, more of customer trust thing, right? Hey, something happens to overlay, can you just converge back to my MPLS network? So, but more of migration is what we see.
Because remember, SD-WAN doesn't work until it's proven to work. But I'm not going to buy it and prove it first.
Does it matter how the routes are learned at all? Or not learned, but let's say you're peering with BGP on one and you have OSPF with another service provider for whatever. Does it matter how those routes or how those tunnels are built or anything like that?
No.
Not at all?
No. I mean, in fact, we are also designed to replace the router completely. So that's the design philosophy. Yeah.
That dovetails very nicely into my question. So you've got, a handful of routing protocols there that you've done a nice job of abstracting away, but at least one of those is a protocol that can scale pretty large. Can you talk a little bit about the guts and the routing protocol stack that you've got, how large you scaled it?
Yeah, in fact,
what it is?
Yeah, so we use, we obviously support BGP. Mm-hmm. The scale, the way I would say is we have so many SPs deploying it. So the routing is not just on the edge side. For us, edge and the gateway, in fact, which is even more important, where the route scale really becomes critical, is on the gateway. On the branch side, you will see 4 VLANs and 4 routes, and there will be a summary coming from the DC, not a big deal.
Right.
Most of the issue comes up when you have this software instance running in the SP cloud, and it is supposed to be stateless. It can't be the same piece of code that you give customers in the branch. So like you see, we have an edge and we have a hub, which is another edge in customers DC. But the thing in cloud, we don't call it edge for a reason. We call it gateway because it is stateless. It scales infinite, which means it can also give you that infinite scale in terms of the routing, right? So for us, we can support BGP on a per tenant basis from the cloud gateways itself.
Okay.
So for us, like you go up to 500,000, 1 million routes on a gateway, it's not an issue at all. But then these gateways are disposable piece of software. You can have a new gateway and new routing spun up any point of time.
Right. So I mean, you've got it's a software-based routing stack, so you'll be able to consume huge routing tables, right? Whatever the resource constraints are of the physical hardware. What about like numbers of peerings? I mean, after a period of time, you're going to probably run into scaling issues with like 10,000 peerings or something like that.
Yeah. So for that, we'll have MPBGP. So what we'll do is, especially on the gateway, the thing is, if you go beyond 200 VRFs and if each of these VRFs is giving you 20,000 routes, then you start running into some sort of issues. Right. So what we recommend is then now you can start using MPBGP, and especially since we are in SP core, it becomes very critical for us to use that. And then you have lesser limitation. But what we have seen is actually limitation coming from the other side, because the customer will say, hey, I have a ISR 9K or something in my core, and now I'm running into the scale issue on that end. So that is more common, like running into scale issue on the other side where they have all these physical devices.
That's not surprising to me. Now you've got BGP and OSPF in here now. Are those are you adopting common back-end routing stacks, writing your own?
No, we are leveraging Quagga for the routing. Yeah.
Okay.
And we are contributing to it as well.
Excellent.
You sticking with Quagga or going FRR? It's FRR, right?
It's FRR, yeah. It's the,
So we are assessing FRR right now for several reasons, but yeah,
Okay,
we will
that's
move
fair.
to that. Yeah.
So that means possibly in the future you support additional routing protocols, yeah?
We could get some freebies because of that. Yeah.
Yeah.
yeah, FRR 's got
Absolutely.
pretty expanded repertoire of
Yeah.
things it supports.
Repertoire.
Yeah.
RIP again.
So let me quickly go over one of the use cases and show you the simplicity here. You can see to reach a specific subnet here, 10.0.1.0, maybe it's on a legacy site, you can see there are 3 preferred VPN exits. These are the exit points to reach that subnet. You can see a Dallas branch, a data center, and an underlay. So with a simple click from my OFC, I can change that preference. If I have to compare this with a traditional router, I'll have to touch multiple elements in that branch to make that change, maybe multiple devices too. So just with a simple click, because I want to follow a compliance or because of the enterprise, I can just make this as a, to reach that subnet. Now it will use the underlay network. All the branches or all the network will use that underlay MPLS to reach that destination with just one click. And that's what the routing use case 1 is all about. The second one is about the route preference, where depending on the site, even if you're running multiple routing protocols, branch 1 is running with OSPF and it's learning OE1 routes. Branch 2 is running with OE2 routes. With a single policy push, we can do the route influence based on the local preferences set. So if the if the OFC table says it has to go under route, it has to go underlay, even if there is a better route preference for the overlay, we will adjust our cost and will make sure that the traffic to that subnet always goes underlay.
Just to add to that, so I think what Rohan was saying is like independent of like which routes a branch is advertising into the overlay, we will learn all the routes into the overlay, and then based on the policy that you see over here, inject a less preferred or a more preferred route to attract traffic into the overlay or to push that traffic in towards the underlay MPLS network. And I think we're virtually out of time or overtime already.
We can't overlay time.
Getting the evil eye on the back of the room.
You're about on time.
So I think the key here is the simplicity which we have brought to the routing, and it's not just restricted to routing. There are other SD-WAN features which you have seen, the segmentation, the visibility, the analytics, the third-party service chaining, all those, the simplicity is there with the VeloCloud SD-WAN. I think that's where I would like to end the presentation.
Great, thank you so much, Rohan.
Thank you.
And I think that wraps it up for the VeloCloud portion of the presentation. So thank you all for attending today. It's great to have you all back, and guess we'll see you in the next NFD.